Let me introduce myself. My name is Seth Cobb. I'm the Asset Supervisor for Atomic Fiction, and today I'm going to talk to you about Katana's power for look development. I'm going to show you how we look dev entire environments using a single shader, and I'm going to go over some procedural techniques to cut down on the asset build time. But let me first introduce Atomic Fiction. We're a team of artists, designers, and technologists. Our mission is to create content that invokes emotion, inspires discussion, and becomes rooted in popular culture. So here are some of our past projects, and we're currently finishing up work on Ad Astra, The Predator, the OA, and Welcome to Marwin. So our current team has 325 employees. We have 3 locations. We have a studio in San Francisco that handles the bulk of our animation. Los Angeles is in charge of new business and finance. And Montreal is where we have our 2D and 3D departments located. And we've been in the Montreal office for a little over 4 years now. So right now we're using Katana with RenderMan. But in the past, we've used Katana with V-Ray. And that's important to mention because we were able to make the switch from V-Ray to RenderMan with very little impact on our pipeline, because Katana is render agnostic. So why do we use Katana at Atomic Fiction? It has a powerful node-based interface that makes look dev fast and efficient. It's highly customizable, and you can customize the interface, the layout, and the shelves to suit the artist, task, or show's needs. Katana allows you to create templates so you can blaze through look dev. Some of the things that we typically use templates for are buildings, vehicles, plants and vegetation, rocks and debris, and even sometimes characters and creatures. So as I mentioned before, Katana is render agnostic. And we've tested a variety of renders with Katana, and we've used both V-Ray and RenderMan in production at Atomic. Also, we've built up a custom material library. This greatly speeds up the look dev process. And for some assets, the only thing required is for the look dev artist to plug in the maps and render. So now I'm going to talk a little bit about how we use a single shader to look dev an entire environment. So this is one of our shots from Blade Runner 2049. So let's take a closer look at the shot. So it was a key shot that we used to develop the look of our city environment for the project. And it was challenging artistically because the director wanted the city to feel massive, but also very dark and moody. And we wanted to be able to throw as much geo as possible at it, but we didn't want to get caught up in texturing every single part of the environment. The environment went through a lot of iterations, so working smart and keeping the team small was a key to success for this environment. So just myself and 2 other artists were responsible for the 3D build of this, and no DMP was used. So let's break it down a little. So using geometry instancing for all the small scale detail, we were able to load this environment up with a massive amount of geo without incurring heavy render times. With Katana's deferred geo loading and processing, you can load this up inside Katana and immediately start working. So no need to wait while your scene file starts up. So what are some of the key concepts behind the creation of this environment? So first, I created a procedural dirt system. Then we used geometry tags to denote material type. And using Katana cell statements in conjunction with collections, we never had to assign any shaders manually. I used a single shader to look dev everything in the environment, including concrete, glass, rubber, different types of metal, all of which were treated procedurally with some combination of water, dirt, and rust to give the buildings the desired look. So this is what we call the master-child material workflow, and it all made this possible. So this is a procedural dirt starting point. And so how did I make this? This is occlusion, biased in specific directions, combined with noises and drip maps to get dirt in all the nooks and crannies. So we get a sense of grunge and water damage over the entire environment without painting anything in UV space. This is a procedural setup that can be copied from environment to environment or even from show to show. All you have to do is swap out the dirt masks, change the noises to get a different look that suits your needs. So using geometry tags in conjunction with collections, it allows us to start the look-dev process before modeling is even finished. And also, it allows us to continually update the geometry, and the material assignments just go along for the ride. So now I'll talk a little bit about our single shader workflow. This method can be implemented using any renderer, but for Blade Runner 2049, we were using V-Ray. I'm going to dive in and get a bit technical, so bear with me. Our single shader setup is basically an Uber shader, and we use this in around 95% of all look-dev cases. The only things we don't use this for are shading volumes, points, and hair and fur. In the Uber shader, we use wildcards to subscribe to published texture maps. The location on disk for these maps are added automatically as attributes to the geo when we import them into Katana. This allows us to attach maps to the appropriate geometry with no manual setup. So on the right, you can see a path on disk to all of the maps. But let's say you're in look-dev and you want to swap some of them out for something procedurally or something that you've generated yourself in Nuke as a look-dev artist. And you wanted to swap them for a second set of maps intended only for a specific material or a specific object. You can override the path to the maps as an attribute edit on the child material and choose a new set of maps without affecting the path of the published maps to all the other materials in the scene. So you can see there that the path of the diffuse has been overridden on the child material level. So as you can see, we have a texture map field for all possible shader inputs. So anything a texture artist paints will have the field automatically connected to the shader. No need to hook up anything manually. We've included some geometry attribute statements on our Uber shader so you can control things like displacement bounds and geometry attribute modifications. We've also set up a few smart inputs like our metallic mask input, where when the shader detects any input, by default, it lowers the diffuse to 0.04, sets the specular color to 1, sets the IOR to 1.6, and the extinction coefficient to 5. But these default values can be changed later using the child material setup. So let's get a bird's eye view of what our Uber shader looks like. So here it is. It's nice and clean, easy to follow. Let's take a closer look. So we have this node graph tree for every map type being piped into the shader. But here we have diffuse as an example. So this is the layout of the node graph. So first we have the texture map input. We have a color correct node for remap operations. So we have an RGB mask input, and then color correct node for remapping inside those masks. It's pretty straightforward. All of that gets fed into our surface material. And the beauty of this workflow is that inside this master material, you can add any number of nodes, and they'll be available to all of the children downstream. So let's take a closer look at the master-child material workflow. So at the top of our node graph, we have an Uber shader that I've described in gray. And then under that master material, we have the children in orange. All of those represent our material library. So those child materials don't contain the master's entire shading network. They only contain their own cell statements, their own object settings, and slots for their own texture map subscriptions. But these are only overriding the shader attributes, and only per the child cell statement. This next part can be a little bit tricky, and it can kind of feel like you're in the matrix at first. But In addition, Katana allows you, by using a network material parameter edit, to add any of the attributes for the nodes inside the master to an override list on the child. So to put it simply, if you create something inside the master, like the procedural dirt setup that I mentioned, or a color correct node or anything, you have access to add and override any of those parameters as an attribute edit on the child material. So the result of this is the ability to create a single shader and then make a series of overrides to change the attributes to create almost any material type. So this is a really powerful and efficient way to leverage some of Katana's features. And so since I'm a visual learner, and I imagine most of you guys are as well, I'll walk you through the process step by step. So let's dive into the master material. So this is inside the master. And let's add a node. So inside the master material macro, I've added a color correct node with the name PXR color correct desaturated and set the saturation to 0. And so what I'm doing here is I'm completely desaturating the diffuse in the master for everything associated with that material. So let's jump back out. Now, downstream of the master material, we can add this new node to any of the child materials using a network material parameter edit, bundled inside the child material macro. So we can see here that the values are currently being inherited from the master material. So the saturation is 0. But we can change the attribute for just the child material by modifying these values. So now I've set the saturation to 2. And what this is doing is it's only affecting the child material saturation and doesn't affect the saturation of the master or any of the other child materials. So this is what the inside of the child material looks like. The actual Katana node that allows for this workflow is, as I mentioned, the network material parameter edit. So if you have more nodes, if you add more nodes to the child, so this is where they'd show up. So let's take a look at some renders. So this is a basic example of using a single PXR surface used to shade 4 completely different material types. So on the left, I have some snow, then gold foil, concrete, and wood veneer. Let's take a look at the layers so you can see how different each material can look. So this is the diffuse pass. And you can see that the diffuse on the gold foil is significantly reduced. And this is all using a single shader. So this is the subsurface pass. And we can have subsurface on some materials without having any on others. And I've added a bit of diffuse transmission to the snow to showcase how far you can push the shader differentiation. You can add refraction, anything. So this is a specular. And again, you can see the gold foil has quite a bit more contribution in the spec, more so than the concrete and the snow does. So this is the final beauty again. So, whoops, let me back up. So why would we want to do this? Every time you hit render, Katana has to bring in and evaluate each of the nodes in your look-dev scene. So for every object in your lighting scene, it has to bring in all of those nodes, all of those materials, and all of those objects. So let's say you have a massive environment filled with different types of metal, rubber, glass, painted materials, refractive surfaces, all that sort of stuff. Every node you add in your look-dev scene adds time to how long it takes the renderer to start rendering. So with this workflow, when rendering, it can drastically reduce time to first pixel, as well as total render time. And your lighting department will love you for this. So this is huge in being able to turn out a lot of look dev and lighting iterations very quickly. It saves you a ton of time if you have massive environments like this one. So this is a scene from the Cloverfield paradox. And we've used the master-child system for this project. And in this environment, we have materials like painted metal, steel, aluminum, copper, rubber, concrete, iron, tin, glass, refractive solar cells. So here's the same environment from another angle. So without using the single material workflow, you'd expect to spend minutes, if not hours, waiting on time to first pixel for every lighting or material adjustment. So here's another breakdown of this environment for the Cloverfield paradox. This is to give you an idea of the size and complexity of the environment. It was massive. The sheer amount of geo that we are throwing at Katana is important to note because all this geo is tagged in modeling, and its shader assignments were done automatically in Katana. But it's also useful in smaller environment builds like this one for Pacific Rim 2. So this building is pretty cool. It was shaded using the master child material workflow and a template. No custom look dev was done to create this asset. We had a few basic materials set up and published into a show template, and then using the geometry tags I spoke about earlier, all the material assignments were done automatically. So this is the same asset, but in another shot. And as you can see, this workflow can be leveraged to handle hero assets as well as background props. So it can be used on simple assets with only a few materials, like the Santa Monica Pier destruction sequence in Pacific Rim 2. And so it's a complicated shot, but the pier asset was pretty simple. So we have a few basic materials. We have wood and wet wood, concrete, wet concrete, painted metal, wet painted metal, iron, wet iron, and steel and wet steel. So all of these were shaded using the master-child material workflow. So to create the wet look on all these materials in the scene, we simply plug in an RGB mask for the different types of water and associate those with the child material. Make a few shader tweaks to the diffuse and the spec to create a wet variation across the entire asset. So even our kaiju was shaded starting with the base master material setup, but it ended up being a lot more complicated, so we diverged, and in the long run, it ended up being a custom setup, but we started with this template regardless. So this base of organization prevents scene files like this from happening. And I'm sure at some point in all of your guys' careers, you've inherited someone's work file that looked similar to this one. It's a giant spider web. And you can spend hours or even days untangling someone else's scene file, or possibly throwing the work out altogether and starting over because the scene is too messy and complicated. So that's lost time and money. So wouldn't you rather pick up somebody's scene file that looked like this? And I would. So to harness all of Katana's power for look dev, follow some of these guidelines. So first, templates are your friend. Second, leverage the master-child material workflow. Third, procedural setups in look dev can save time and money. And finally, create and use a material library. You can follow these steps, and you can start to harness Katana's power for look development. So again, my name is Seth Cobb, and thanks for your time and attention. I have a little bit of time left, so I can open it up if anybody has questions.